Hey guys, today we're going to have a look at the quadratic formula. Now don't worry, it's not as scary as it looks. It's actually just another way to solve quadratic equations when they don't factorize easily. So a lot of people find this easier than factorizing quadratics. However, remember that factorizing quadratics is a skill in itself. All the questions we've been doing up until now have just asked you to factorize the quadratic, not to solve it. So you really can't forget that skill. Let's get started with the formula though. When you've got a quadratic equation like this, ax squared plus bx plus c equals 0, where a, b, and c are coefficients, that is, they're numbers, then we can solve this quadratic because it's equal to 0. We could try by factorizing, so we get one bracket times another bracket equals 0, and then either the first bracket 0 or the second bracket is 0. Or we can use this formula. You hear that noise? Weird, eh? Anyways, so x will be equal to negative of b. So whatever the b value is, positive or negative, we're going to change its sign. So if it was a positive number, it now becomes negative. If it was a negative number, negative of a negative number, that would become positive. Plus or minus the square root, and notice that the square root sign covers all of these terms. So square root of b squared, that's the middle value again, squared, minus 4 times the first value times the last value. So that's all under the square root sign, and then the whole thing is being divided by 2 times the first value. Okay. Let me show you an example because it kind of looks like a confusing formula, I know. So solve this equation. What you've been doing up until now has been factorizing. Now looking at this quadratic equation, it's equal to 0, so that's fine. We can solve it. However, it's got this number in front of the x squared term, which makes me nervous because I know that I'm not going to set up my brackets x and x to make 9x squared. I'm not sure how I'm going to get that 9. Maybe it's 3 and 3, maybe it's 1 and 9, I'm not sure. And I can't factor it out of all these terms. So I need to split the middle term, and I'm thinking 9 times 5, 45. What numbers multiply to make 45 and add to make 15? And I can't figure out what those numbers are. And there's a hint here. Give your answer correct to 3 significant figures. That means those numbers I was trying to think of that multiply to make 45 and add to make 15, they'll be decimal values that are probably non-terminating decimals that I need to round to 3 significant figures. I'm never going to be able to think of those numbers. So anytime you see give your answer correct to 3 significant figures, in the case of a quadratic, you're using the formula. Okay, so step 1, let's identify the values of a, b, and c. As you can see, I put them in colors here, so you can see that a is clearly just the 9, not 9x squared. Do not put the x squared into the formula. B is positive 15, and c is 5. Step 2, we're going to substitute those values into that formula. So I've done x is equal to the negative of the b value. The b value is 15, so it's going to be negative of 15. Plus or minus the square root of, again, the b value squared, and I put this in brackets. I know it's tedious and it doesn't always look very nice, but it will help you in the future to avoid mistakes. So b squared minus 4 times a, which is 9, c, which is 5, and all of that over 2a, a being the 9. Okay, when you simplify this, it's best if you do it by parts because you're likely to make calculation errors if you do this all at once. Common mistakes people do is they do the square root of 15 squared and their square root sign doesn't cover everything to the end. Or you do divided by 2a and you're only dividing the last term by 2a. So let's simplify this before we calculate it. Like I said, negative 15 is negative 15 plus or minus the square root of, and I worked out what is underneath the square root sign, it's 45, over 2a, which is 18. Okay, now we can calculate this. Step 3, we need to calculate to solve for both values of x. Now remember, quadratics very often have 2 answers. This is going to have 2 answers as well because we're going to do it twice. We're going to do negative 15 plus the square root of 45 over 18, and then we'll do that calculation again, but we're going to do negative 15 minus the square root of 45 over 18. And that gives me these 2 answers to 3 significant figures. Notice that when we round to 3 significant figures, that doesn't always mean we're rounding to the same place value. This number to 3 significant figures is rounding to the thousandth position, while this number rounded to 3 significant figures is rounding to the hundredth position. because this 0 in the units position is not a significant number. It's a leading 0, and they're not significant. Okay, let's go on to another example. You might want to try this for yourself. We've already done one example. You've got the formula. You know the steps. Hit pause if you want to try for yourself. Solve to 3 significant figures. That means you want to use the formula. Step 1, identify values A, B, and C. Step 2, substitute those into the formula. Step 3, let's calculate that a little bit first. Now let's calculate to find for x. That's for both values x. One of them is where I'm adding the square root of 40, and one of them is where I'm subtracting the square root of 40. It's going to be negative 0.279 or negative 2.39. 3 significant figures in both cases, but one of them is to the thousandths while the other is to the hundredths. Okay, now you may have a hang of that, but let's switch this up for you. What about when b is negative? Now I've already pointed that out to you, that if b is a negative value like it is in this quadratic, I've got negative 8 here. The first term in the quadratic formula is negative b. So negative of negative 8 is changing the sign of that negative to make it positive. Right? My values are a is 3, b is negative 8, c is negative 7. Notice that I'm not including the x's as my variable numbers. A is not 3x squared, it's just 3. B is not negative 8x, it's just negative 8. Substituting that into the formula, you'll see now that those brackets are helpful. In fact, they are necessary. The negative 8, you might just directly put that in as 8. But if you don't put the brackets around this negative 8 and you square negative 8 without brackets, you're going to get negative 64. With the brackets, you get positive 64. Right? Because the brackets tell me that I'm squaring negative 8. I'm doing negative 8 times negative 8, and a negative times a negative makes it positive. It's one of the most common mistakes when people are using this formula is they don't use the brackets, and they have these mistakes with their positives and negatives. Okay, working that through a bit, I've got positive 8 plus or minus the square root of 148, all of that over 6. And working out my two answers from there, I've got 3.36 or negative 0.694. Once again, the 3 significant figures does not mean to the same place value. Right, here's one for you to try on your own. Another negative b example. Solve the 3 significant figures. Start by setting out what a, b, and c are. Substitute those into the formula. And remember, calculate both x values. Here are my a, b, c values. There I'm substituting into the formula, using brackets, especially with that negative b. And there's my simplified formula and my 2 answers to 3 significant figures. So hopefully you're now feeling pretty confident about using the quadratic formula. You can just substitute values in, add for one answer, subtract for the other answer, no problem. But here are some common mistakes. Your calculator is not broken. Sometimes you might see calculator error or math error on your calculator. That's not that your calculator's broken. So don't do this to your calculator. I've seen some of you do it in class. It's not helpful. The problem is there are 2 things we can't do in math. And one of those things is divided by 0. As you can see from this formula, you do need to do a division here. And some people think that a is sometimes equal to 0. A will never be equal to 0 for a quadratic. Because look at it, if a was 0, 0x squared would be no x squares. And if the x squared is gone, this is no longer a quadratic. You wouldn't be using the quadratic formula to solve it. So a is never 0. Never. Now I know some of you are going to say, what about quadratics like this where there's no number in front of the x squared? There is no number in front of the x squared because there's only one of these x squared, not 2 or 3 or 4. There's no need to put a number in front of it because I can see there is an x squared there. There's one of them. So in this case, a is 1, not 0. Okay? The other thing we can't do in math is square root a negative number. And you can see in this formula as well, there is a square root. That cannot be negative. Now, that's actually a very interesting part of this formula. We call b squared minus 4ac the discriminant, because in the formula, that is the value, or this expression within the formula that determines what one value is for x as opposed to the other value, because it discriminates between the two values. It's the difference between the two values, right? Now, if the discriminant is 0, we can square root 0. The square root of 0 is 0. And the nice thing about when the discriminant is 0 is we'll do negative b plus the square root of 0, which is negative b, divided by 2a, or we do negative b minus the square root of 0, which is going to be negative b over 2a. So if the discriminant is 0, this quadratic will only have one solution, right? If the discriminant is positive, we can square root positive values. So if this is positive, when we square root it, we'll get an answer. It may not be nice, it may not be rational, it might be a long non-terminating decimal value, but it is a value. And if I add that value or subtract that value, it'll give me a different answer for x. So if the discriminant is positive, we know that there will be two possible answers for x. If the discriminant is negative, so if this is negative, as I said before, we can't square root negative numbers. That number would come up as an error on your calculator. It's not that it doesn't exist. There actually are the square root of negative numbers, but those are imaginary numbers. And imaginary numbers do exist. Just ask my imaginary friend. But you wouldn't understand her anyways because she's an A-level student. So yeah, when we square root this, if it's a negative number, basically what that means is that there is no solution to this quadratic. Now, that should not be the case with these beginner examples. So if you've got an error on your calculator, it's probably that you made a mistake here. So check. If b was a negative number and you squared it, when you square it, it should become positive. That's why you need the brackets there. Any negative number multiplied by itself will become positive. And any positive number multiplied by itself will become positive still. The reason this might be negative is because it's a negative 4ac. And it is possible that 4ac is big enough to make this a negative answer. But it shouldn't be in these beginner examples. Okay? It is also possible that you've made a mistake with this minus 4ac, where you've left out a minus sign, either an a or c. Because if I do negative 4 times a negative number, that'll make this plus, right? Okay, so those are the possible mistakes that you might be making. So if you get an error, double check your calculations and always do those calculations first for yourself and write them down. Don't just substitute the whole thing into your calculator, otherwise you won't find that mistake. Right, let's go on to the practice. To solve these quadratic equations to three significant figures. Remember, if I see to three significant figures, I'm going to use the formula. I'm not going to try and factorize. Looking at the first two there, they look pretty straightforward. They are quadratics, x squared term, x term, number term, equal to 0. That's fine. Second line as well. They all seem fine. Third line as well. Watch out because there's no number in front of the x squared, but that means 1. And there's no number in front of the x, but that means negative 1. Okay? Don't put zeros where they don't belong. Next line should be okay. Questions 9 and 10, though, they're obviously going to be the hardest ones. They're the last ones you need to do. Notice that they're not equal to 0. So you're going to need to make them equal to 0 before you can use the formula. So pass these terms to the other side. Question 10 as well, not equal to 0. And I've got a bracket here. You're going to want to expand this bracket out and then pass these terms over to the other side. So you make it equal to 0. You've got a quadratic equal to 0. Find out what your a, b, and c is and use the formula. Make sure it's equal to 0 before you decide what a, b, and c are. Okay? Hit pause now and give yourself a chance to work those through, and the answers will come up in just a minute. I hope you've hit pause. Here come the answers. There's that noise again. What is that noise? Okay, questions 1 and 2. Questions 3 and 4. Question 5 and 6. Questions 7 and 8. Questions 9 and 10. And you will notice that some of my answers are not quite right. Why not? They're not the three significant figures. Here they are corrected. That's more like it. Now there's that sound again.
X is equal
I'll
to
leave you with this fun
negative b
song.
plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.